Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, I am going to discussing about the breast cancer predictions using Python and machine learning. This is an advanced types of machine learning projects. Let's see the today's agenda. What are going to be covering on this project? First, we are going to discussing about the data preprocessing. Then we have the EDA, also called the exploratory data analysis. Then we have the feature selection in order to select some best feature from our data set. Then we have the data scaling, also called the standard scaler. Then we have the various machine learning algorithm. We're going to apply some various machine learning algorithm and try to predict it. Then we have the hyperparameter tuning in order to getting some best parameter from our machine learning algorithm and try to predict it. Then we have the model comparisons. So we have several types of machine learning algorithm. We have to select the best model from all of the machine learning algorithms. Now, बिना किसी देर के हर हर महादेव बल के start करते हैं tutorial. In order to building the breast cancer predictions, we're going to using a data set called the breast cancer data set from Kaggle. And this is a data set having the 32 columns. So I'm simply going to download it from here. And now let's go on the Jupyter notebook. So here is my Jupyter notebook. You can also use the VS Code, PyCharm or Google Colab itself. I already downloaded the dataset and also unzip it. And I get here a file. It's called the breastcancer.csv. And also you can see here a file. It's called the IPYNB file. It's nothing but one empty file. Okay. Now in this file, I'm trying to do the coding part here. First thing first, I'm going to importing all the necessary library. So I'm going to import here pandas as PD. Then we have the numpy as np. Then we have our seaborn as SNS. So pandas actually help you to load in the data set from your directory, and numpy actually help you to do some the multi matrix calculations. So that's why I'm going to using here the numpy. Then we have the seaborn, import seaborn as SNS for the data visualizations. Then we have our matplotlib. So import matplotlib.pyplot as plt. It's also one visualization library in Python. So now I'm going to importing here the missingo. So let's call missing zno as msno in order to checking for the missing value. And we go to the data preprocessing tag, we need to also checking for the missing value on our data set and also the categorical value also. Then I'm going to importing here the warnings. So warnings, in some cases it will give me some warnings when you're trying to plot using the matplotlib or the seaborns. It will give you some warning. So I'm going to try to remove all the warnings, filtering all the warnings from my kernels. So warnings dot filter warnings. You can also use the tab from your keyboard and it will give you auto suggestions, filter warnings, and I'm going to give here my actions, and my action is nothing but ignore. Okay, ignore. Then I'm going to give here my sns.set sns.set, and I'm going to give here my style so that my graph will look like better. क्योंकि PLT का जो extraordinary जो ग्राफ है ना, default graph वो अच्छा इतना अच्छा नहीं है इसलिए. Okay, so style dot set or not set, actually we already set it. I'm going to give here use. So let's make it ggplot. Simple. Shift enter. You can also using this run button from here. Okay, so our library is trying to load it from our kernel. So now what I'm going to do, I am simply going to read the file from a directory. So for that, I'm going to using here my pd.readcsv, and I'm going to passing here my path, and you can see it's in my same working directory. Just to write, you can see breastcancer.csv. It's my working directory. So I need to give here my path. So let's give here the breast cancer.csv, and let's assign into the variable. Let's call the df equal to pd.readcsv. So it's having some problem. Let's see. No source file or directory. This for breast cancer. It's not center cancer. Okay. So make sure that your file name should be okay, correct. So let's say df.head. So df.head, it will give you 5 row and all of the columns. So you can see it having the 5 row and 32 columns. So 32 columns. So what I'm going to do, I'm simply going to predict this diagnosis. Okay. So if I'm trying to checking the value of the diagnosis, that how many value are available, that's also called the data preprocessing task. Data preprocessing. Okay. So let's checking for my df dot diagnosis. This diagnosis dot, and I'm going to using here my unique for checking the unique value. It having the m and on to the B. So if I go on here, so what is actually M and B? So M and B is nothing but the malignant and the benign. Okay, so it's, let's say, M means malignant, MLLIGNINT. Okay, and B means, it's called the benign. Okay, this is a full form of the M and the B. So we need to predict them, this malignant or the benign. Okay, based on this features column. So we see that it having the two features column. I mean two class that's have the M and the B. So now the question is it a supervised machine learning problems or the unsupervised machine learning problem? Which one is it? Okay. So if we have the data with the features column, that means this is one supervised machine learning problem. It's called the supervised machine learning problem. If your feature column is given, I mean the target column is the given, not feature column. Feature columns means all the features, and this is called the target column. So if the target column is given, that's called the supervised. Okay, supervised machine learning problem. If it's your target column is not given to you, it's called the unsupervised machine learning problem, also called the clustering based machine learning problem, also called the unsupervised machine learning problem. Okay, so this is one supervised machine learning problems. Now what I can do, I'm simply going to do some data analysis on our data, like describe our data to checking the information regarding the data, and also checking that is there any missing value or not. So for that, first I'm going to using here dot df dot describe in order to checking the distribution of the data set. So you can see here it have been the count, the mean, the standard deviations, the minimum, 25% percentile, 50% percentile, 75% percentile. Which one is really important when you're trying to checking for the outlier in your data set? Then you have the maximum number of value. So if I'm checking the information regarding my data, let's say data.info. So it will give me the information regarding my data. So you can see here it having the 30, 0 to 31, that's mean 32 columns, and each column having all the values nothing but float 64, and one having the integer, and one is objects. So object is nothing but my id. Okay, now let's checking for the missing value. So missing value, just checking for the missing value. So what I can do is simply going to use here df dot isNail, or you can also using here the isNull. Okay, let's take it. Okay, you can see here you don't have any missing value in our data set. You can also using here the isNull. So if I using here the isNull, it's also same things. You can see here it don't have any missing value. So we actually import here the missingo. Okay, you can also using this missingo in order to do the plotting on your missing value. So for that I'm going to using here this missingo. Okay, I'm just going to copy this out, msno, and I'm going to using here for checking the missing value in a bar plot, and I'm going to passing here my df, and I'm going to give here some colors. So let's give here red color. Okay, so now you can see it don't give me the error. That's why actually importing here these warnings, so that it don't give me some warnings. Okay, now you can see here all the features or the features column. Okay, and you can also see here all the value. It having the 569 values, no missing value here. So we don't need to handling that missing value from here in this data set. Okay, that means there uh, are no missing. Okay, that's called missing value in the data set. In the data set. Okay, I mean no missing value, so we don't need to handle it out here. Okay, now what I can do, I am simply going to checking for the distribution of my diagnosis, because if I checking for the diagnosis, this is nothing but my target class. I need to checking that if the data is a balanced data set or the imbalanced data set. So how can I do? I can using here the plt.hist, and I'm going to using here my df of diagnosis. So my diagnosis, this one, diagnosis, just copy this out, diagnosis here, and I'm going to paste it here, this one, and I'm going to give here the title. It's called plt.title, and I can give here the diagnosis. So okay, let's copy paste it out here. Okay, hum lazy hai isliye. So diagnosis, and what I can do, I'm simply going to give it, there's a malignant equal to m. Let's make it inside one single vector so that it's look better. So malignant, uh, again inside that. Let's say malignant equal to 1 and the benin also equal to 1. That's nothing but the type of that. Okay. uh, so now what I can do is simply going to use here the plt.show for showing the distribution of the data set. And now you can see here it having the malignant equal to low amount of malignant, and you can see benins is nothing but the higher amount of the benins. Okay. You can also using the df.describe. Okay, let's use the df.describe. Okay, describe. So you can see here uh okay, you don't need to why did you describe what did it. So you can see here the distribution of the diagnosis. Okay, diagnosis is nothing but the lower number of malignant and the highest number of the benign. Okay, now what I can do, we can simply um, going to do some more exploratory data analysis, that's called the EDA. So let us start the EDA part from here. Okay, for that I'm going to take some shells. Okay, so this is my distribution. That's mean our data set is not quite imbalanced data set. So now what I can do, I'm simply going to plot some density graph, density graph, so that I can checking for my distribution of the data set, and also checking that is there a null value or not. So for that, what I'm going to do, I'm simply going to iterate to all the columns from my data set. So column in my df. Okay, then after that, what I'm going to do, I'm going to checking for all of the values, all of the values I mean all of the values, I mean 32 columns. Okay, I can checking this out. So what I can do, I am simply going to creating one float number. So let's say if the float number is less equal to 33 30, because it having the 32 features. So except the diagnosis have the 31, and also the accept the id, it's having the 30 columns. So let's make it float number 13, and I'm going to using here the plt.subplots. Okay, and subplot, we can also using the subplot here. So in each column it having the all of the features. So let's say we have the 30 features. So what I can do, in each row, it having the in each row it's having 6 column. Okay, I mean each 5 rows it having the 6 column, each 5 rows it's having the 6 column. So just for that, what I can do, you can simply pass here 5 into 6. Okay, you can see each 5 rows it's having a 6 column. In the 6 column it's having the density graph. Okay, it's the having a density graph. So I'm going to giving here the float number. So float number, let's try to pass it out, float number, and let assign into the variable that's called the axis. So called axis. Okay, axis. Now I'm going to using here the sns.distplot for density graph. So dist plot, and I'm going to passing here my df of all of the columns. So this my columns is iterated to from here. Then I'm going to using here the plt.x level for showing which graph is it is. I'm going to give here my columns, and now I'm going to increment the number of the plot number. So let's say float number, this float number, let's make it plus equal to 1, so that it will increment by 1. And after high and low is a loop is trying to iterate all the columns from the variables called the df, it will try to increase the plot number. And then I'm going to using here the plt dot tight figure, I can using here the tight layout. Then I'm going to using here the plt dot show, simple as it is. Okay, simple as it is. Now I need to also initialize this plot number before that, so that otherwise it will give me the errors. So let's initialize it the 1, and also I need to give him a figure size. So for that I'm going to using here the plt.figure, otherwise the figure size is not showing up. And to give here the fixed size. So let's give here the fixed size, let's say 20 comma 15, 15 comma 15, and now shift enter. So we got some error, not convert the string to float em. Okay, m, it's not convert to floating point numbers. Maybe it's having some problem on here. Okay, let's go up and checking for the numbers. If the float number is nothing but get equal 13, maybe it's having the problem of the on the Okay, diagnosis one. So that's why it's give me some errors. So what I can do, we can simply convert this m to the 0 and b to the m to the 1 and b to the 0. So for that I need to also convert this categorical feature into numerical features for the diagnosis classes. So that's why I need to also do it here for the data preprocessing. So let's taking one shell after the missing go. Okay, it's idiot here. Okay, so you can see I need to convert this m into the 1 and b into the 0. So before that I can also do this out so that my graph is looks better. So what I can do, I am simply going to using my df dot diagnosis because I need to also handle in this categorical features. That's why I miss it out. Okay, so now what I can do, I simply going to using this df diagnosis. I'm going to copy this out and I'm going to apply. So apply. So better we can using here the map. Otherwise you can also using here the lambda. But in the most of the cases, I actually using the map, just mapping this value. Now let's use the lambda function. Lambda, if the val is equal to 1, okay, if the val equal to 1, that means make it the val should be the m. I mean, if the val equal to m, if the val equal to m, and then making this value as a 1, and otherwise I'm trying to make it 0. So else, and otherwise return 0. So if I am shift enter and try to print it now you can see here all the value you can see here now converted into the now some point. Okay, you can see here 0. In before you can see here the m and the b. Okay, okay, so you can see here m means 1, it's mean the malignant, and it having the benigns. Okay, have the feature I mean the most number of the features. Now if I'm trying to run it out, and now you can see here it will try to run it and try to plot the diagram. Let's call the density graph. Okay, sns dot plot. So it will take few times. You can see here this is my density graph. So if I see this inside the graph, you can see here this is my graph, and this is my graph, and this is my graph, this is my graph. So look like the density graph is quite good. Some outlier also have here, few of them not so good, few of them. Okay, so this is nothing but my density graph. See, how I am trying to using any machine learning algorithm before that, and to also handle the categorical variable. So we have one categorical variable that's called the diagnosis, and also this is nothing but a target class. So how I'm trying to plot it out, you know, to give here also the numerical types of value. It not recognize the categorical types of values. That's why it's not showing up here. Okay, it's not showing up. So now what I need to do, I need to also explore this data set deeply. So for that, I'm going to also try to printing the correlations between my data set. So for that, I'm going to using here the df.code for checking the correlations. So this is nothing but my correlation of the data set. Now you can see here it having that also diagnosis, because we convert this diagnosis into the numerical column. So that's why it also showing me the correlation matrix. Otherwise, it not showing me the correlation matrix, because correlation matrix is not applicable on the categorical data set. I mean categorical data. Now what I can do is simply going to create one heat map so that our correlation matrix is looks like in a graph. So for that I can using here the plt.figure. First give here my fixed size. So let's say fixed size, and I'm going to using here let's say 20 comma 12, and I can using here my sns.heatmap. Let's say sns.heatmap, and I'm going to passing here my df, just simply df dot correlations. Okay, and I can using here the palt dot show, like that. So like give me the heat map. So you can see this is my heat map. I'm in the correlation matrix, but it don't have any values right now. In the correlation matrix, it having the values. Now what I can do is simply going to printing just the diagonal types of value, because it's we don't need it. We don't need it. Just this diagonal types of value need it. Just this value we're going to just going to printing it out, and after that you're going to checking all the highly correlated feature and try to remove it from a data set. That's called a feature selection part. So what I can do is simply going to define a variable that's called the correlations, and I'm going to using here the df.code. Now we simply going to creating one marks, and just we're going to remove it, just remove it this part. We don't need this part. So we're just focusing on this part. So what I can do is simply going to creating here np.trio, so that we can printing the diagonal series. So we can using here the np.once like, okay, once like, one or once like, okay, just once like, किधर गया, once like. And inside that I'm going to passing here my correlation value and also my data type. So data type is obviously bool, it's nothing but my boolean value. I mean which value is going to printing it out. It's called the marks. So we're just going to calculating this portion. So for that I'm going to passing here my correlation, that's these correlations. And for marks I'm going to passing here marks, this marks, and also the line width. So giving here the line width, let's give here the one, and also give here the annotations. So let's make it the annotation should be the true, and also giving here the fmt so that it's look better. I mean the how many floating point or numbers. So let's give here point to f. So now let's print it out. Now you can see here, this is nothing but marks, it's not painted. And you can see here all the value in the correlation matrix. Okay, all the value inside my correlation matrix. So this is how you can actually painting one correlation matrix with the marks. Now you can see here there are so many features. It's having the 32 featured columns, except the diagonal for the id, it having 30 columns. So it actually causes the multicollinearity because it have a multiple number of features. So you have to select some best feature and try to drop some feature from our data set. This is called the feature selections, right? So there are so many actually highly correlated value. So its causes actually the collinearity. So that's why you need to also remove these highly correlated features. So highly correlated features, I just need to drop it out from my data set. So it is causes the multicollinearity. So let's make it multi collinearity. Okay, so that's why I need to also remove some features column from my data set so that it's not highly correlated. Okay, so I'm going to comment out those lines. So I need to also checking that which features having the positive correlation and which feature having the negative correlation. If I see it here, it having the negative correlations, it also having the negative correlations. Okay, having the negative correlations. So we're just selecting some features which are highly correlated. I mean same feature having the same correlated value, so we can drop one of them. Okay, drop one of them. So for that I'm going to removing the highly correlated features. So what I can do, I'm simply going to creating one same this kind of correlation matrix and try to remove all the negative positive features, I mean highly correlated features from my data set. So for that I'm going to using here my correlation matrix. So let's say correlation matrix, let's say df dot core, and I'm going to using here my absolute value, all of the absolute value, I mean positive and the negatives. So after that I'm going to creating here the same marks that we created, the same marks I created, just going to pass it here. And after that I'm going to passing here my correlation matrix, this correlation matrix with having the absolute value. Now I'm also creating here the marks of that. So for that I'm going to using here this correlation matrix dot marks, and inside that I'm going to passing here my marks. Okay, this marks. So this is nothing but my try difference, try df. Okay, we don't having the highly correlated features. Now what I can do, I am simply going to drop all of the highly correlated features. If I see that there are some value which one is greater than, if I see here, there is some value having the one is correlated, means correlated, highly correlated, 7 3, and also having some features maybe 92. You can see here 96, we can drop this out. 96 we can drop this out. 97 we can drop this out. 94 we can drop this out. And we have the uh, 96 again, 96. Okay, we can drop this highly quality feature because it's not necessary. It's not necessary in order to building our machine learning model. See, in the radius ORs and the perimeter ORs, it having the same I mean the same highly correlated features, so we can drop in any of them. Okay, so for that what I can do is simply going to create the marks. Now we're simply going to creating if the any value is greater than the 92%, so we're going to simply going to drop it out. So for that we're going to creating here one variable that's called a to drop. So we can iterate to all the value from here. So x in the try difference, because we already creating here marks, all of the value from the marks, this marks, I mean all of the value from this marks. So after that I'm going to checking all the columns from my difference value. So columns, okay, if any, okay, if any try difference, I mean because it's nothing but a triangle, okay, it's we put the marks. So from try difference, if any of the value from the x is greater than 92, 0.92, so we're simply going to drop it out. We're simply going to drop it out. So x idhar aayega. Okay, this is nothing but my drop features. So what I can do is going to first creating here one correlation of the absolute value, because we're already creating here a marks of that from the triangulations, also called the diagonal vector value. And you can see here we're creating here the trie. Okay, then after the creating here marks and pass these marks inside my trie_df variable, and inside this trie_df variable it will having all the features column. Now if the all the features column having the greater than value, I mean the highly correlated value is greater than 92%, we're simply going to drop it out from my data set, from my actual data set. So if I'm trying to print it out, so let's say to drop, so which feature I'm going to drop it out. So you can see here there are some features called the radius mean, perimeter mean, area mean, concavative means, radius SE, perimeter SE, radius odds, perimeter odds. We can drop those features from my columns. Okay. So now what I can do is simply going to drop it out. Let's say df dot drop, and I'm going to passing here my to drop here, and I'm going to make in x is equal to 1 so that it can drop it from the columns. Now if you're trying to print it out, let's say print df dot shape of the 1 so that we can checking for the shape. So we have in the 32 columns. So if I'm trying to now run it from here, and now we have the 32 features. So I need to also drop it out and also assign into the our data set. So now if I print it out, you can see we have the 24 feature column. We have the 24 features column. So we can also dropping the id, because id is not necessary here. So you can also drop this out. So what I can do, we can simply go into using here the df dot drop the id and also diagnosis. How you drop it out. Okay, so we can simply dropping it out. So we can simply using here one shell, let's call df dot drop, because we do need the id is not necessary here. So we can simply passing here my id and also giving here my axis equal to 1, and let's say in place equal to true, in place equal to true. Okay, so true, true, true. Okay, let's assign into, let's say df, then we have the id. Let's copy this out. Okay, I think I don't need to put it inside it out. Okay, you can see right now you have the 23 features column. If I try to checking the df head, so it don't have in the id. Okay, it don't have the id. So you have the 23 columns. It's called the feature selection part. It's called the feature selection part. It's called the feature selection. Okay, so we have the 30 features, 32 features, 32 feature. We reduce it 23 now. Okay, so this is how you can select the features, best feature from your data set. I mean, if you have the multiple number of features, so you can select some best feature from your data set and try to remove it like this way. Okay, now what I can do now, we're going to select some machine learning algorithm in order to do the analysis. I mean, in order to building one predictive model. So for that, I need to also divide our data set into dependent and independent features. So for that, I'm going to using here the x equal to df dot drop. I just need to dropping the which column, just the diagnosis. Now why drop actually? Why drop q? Because except the diagnosis column, I am going to put all the value inside my x independent variable, and in my dependent variable I have my df dot. You can use the df dot drop. Otherwise, you can using this kind of diagnosis. Okay, diagnosis. Now we divide our data set into the x and the y. I mean, dependent and the independent features. Now what I can do, I am simply going to splitting my training set and the testing set. So for that, I'm going to importing it from here. So from sklearn dot model selections. So you can also use the tab from your keyboard. I'm going to importing here the train test split. Import the train test and split. Then after that, I'm going to pass my data set inside my train test split. So let's say train test split, and I'm going to pass here my x and the y, and I'm going to give here my test size. So test size, let's give here 0.2, and I'm going to giving here my random state equal to 0. And I have to assign into the 4 variable. So let's make it here x train. Then we have in the x test. Then we have in the y train, and we have in the y test. Simple. Shift enter. So we divide our data set into the train, test, and split. Now what I can do is simply going to scaling our data. We're simply going to scaling data. Well, so let's take some shell also. Okay. So now to scale our data, we're going to import it from sklearn. Sklearn dot preprocessing. We're going to importing here the standard scalar. So stand.scalar. And now we're simply going to creating one instance of that standard scalar, and simply going to assign it to the variable. Let's call it scalar. Then after that, I'm going to using the feed transform here to feed our data, because this is our training data. Feed transform. When you're trying to feed, when you use the feed and when you don't use the feed here. Okay, I mean when you use the feed and when you need to use the feed transform. So when you are going to use the standard scalar in your testing data, you need to using here the feed. But when you are using the standard scalar into your training data set, you need to using the feed and transform. Okay. Now I'm going to using here my x train. So x train. So this is nothing but my x train. And now I need to using the transform inside my test data. So scalar dot transform. Okay, just transform to our test data. Okay, so let's make it x train. Okay, let's make it x train. So the x test. Okay, so when you're trying to using the train data, we can using here the feed transform. Thoda ulta ho gaya. So when you actually using here the transform, we're using here the test data. Okay, that's it. So you scale our data set. If you're trying to checking my x train dot head, so it will give me my error. Yeah, it's give me the error because it's now converted into the numpy array. Okay. Okay, if I try to checking the shape of that data set, show shape. So you can see the shape of the data set. It having the 45 rows and 22 columns, except the diagonals. That's why it having the 22 columns, features column. Now what I can do, I'm simply going to apply the machine learning algorithm. Apply machine learning algorithm. Machine learning algorithm. Okay. So first I'm going to import here the logistic regressions. Okay, for that I'm going to taking more shell and apply it. Okay, so first I'm going to import it from here from sklearn dot linear model. We have in the logistic regression, import the logistic regressions, and I am simply going to creating one instance of the logistic regressions, and I'm going to save it inside a variable that's called the lock reg. Now I'm going to simply going to fit it out. So for that I'm going to using his variable. It's called the lock reg dot fit on my x train and also my y train. Okay, so it's fit in our data. Now what I can do, I'm simply going to predict it. For the model predictions, I'm going to using this lock reg, and I'm simply going to use the predict, and I'm going to simply predict it on my test data. Okay, not c test, it's having the x test. Okay, so this is my y predictions. So y predictions. Okay, so if I try to checking my prediction, so this is my prediction value. It's predict on the test data set. Now let's checking for the accuracy score. So for that, what I can do, let's take some shell also. Okay, so what I can do, I'm simply going to import it. So from sklearn dot matrix. So matrix, and I'm going to import here the accuracy matrix or accuracy score. Then you have in the confusion matrix, and you have in the classification report. We're simply going to import it here. So now first going to importing first trying to actually printing the accuracy score. So for that, I'm going to using here my accuracy score, and I'm going to passing here my y train, and I'm going to using here my log regressions dot predict dot predict. You can also using this y predict also. So I'm going to using here my x train. Okay, simply, and after that I'm simply going to print it out. So I'm going to simply print it out. That's it. You can also assign into the variable. Just going to copy this out. You can also copy this out. Simply going to copy this out from here, and I can also assign it the variable that's called the log regression accuracy, because it's needed when you're trying to print in the ROC curve. So log RAG accuracy, and if I'm trying to print it out, so let's try to print it out here, and we have the 98% accuracy on our training data. If I try to check it for the testing data set also, so let's say make it test. So test, and if I'm trying to printing the accuracy, let's printing the accuracy. So I can using his log the accuracy, and if I try to print it out, you can see found input variable inconsistent number of samples. So it having the log regression, the x test. So what's happening? Okay, it's having the x train, and also the why it's happening. Okay, let's try to run it from here again. Okay, again we get some error. Accuracy score simply, okay, it should be the y test. That's why it give me the error. Okay, now you can see we get here 96% accuracy on my testing data and 98% accuracy on my training data set. Okay, so now let's checking for the confusion matrix. So for that we can also print it out here. So print the confusion matrix, and I am going to passing here my y test and also my y predictions, these predictions. So we can copy this out from here, y predictions, and I'm simply going to using it here. Okay, that's fine. Now you can see here we also have in the confusion matrix. So this is nothing but my confusion matrix. So now let's checking for the classification report also. So for that I'm simply going to print it out. So classification report. So classification report, and I am simply going to passing here my y test and also my y predict. Okay, so this is my predictions, I mean classification report, the precisions, the recall, the F1 score, and also the support. So it's quite good. 96%, 99%, 97% is quite good. Okay, so this is how you can actually using the logistic regressions in order to draw the predictions. Now let's try to using some more advanced types of algorithm like KNN. So let's call KNN. So simply I'm going to import it from here. So let's from sklearn dot neighbors. I'm going to importing here the k neighbor classifier. So k neighbor classifiers, and because this is one classification task, so I'm going to using here the, let's say knn equal to k neighbors neighbors. So k neighbors neighbors, simply going to creating one instance of that, and I'm going to using here the knn dot fit, and I'm simply going to using here the x train and the y train. Okay, so if with our data set, now what I can do is simply going to do the predictions. So for that I'm going to using here knn dot predict, and I can giving here my test data, and after that let's assign it to the variable called the y predict. Okay, and you can see the prediction scores. Let's see the predictions. So this is the predictions. So now what I can do is simply going to copy this out from here, the same things, because all of the things are same. So just we can changing this log rag to the knn. Just copy this out, and we need to also printing change this one log rag and anything else. Okay, it having the knn accuracy, it's called the knn accuracy. I'm just going to copy this out, paste it here. Anything else? Nothing else. Okay, so now you can see it also give me the 96% accuracy and 95% accuracy in testing data. This is nothing but my confusion matrix, and also having the precisions, recall, F1 score, and also support. Now let's try to check for the SBM, support vector machine, SBM. So see, this is nothing but the basics machine learning algorithm. You can see here the logistic regressions and also the KNN. Now in the SBM, it having some hyperparameter. Now you can actually using the hyperparameter tuning to select some best parameter inside our SBM. Okay. So for that, first I'm going to importing here. It's from sklearn, okay, sklearn dot sbc, SBM, sorry, not SBC. I'm going to importing here the SBC support vector classifier. I would also do the hyperparameter tuning. Hyperparameter tuning. Okay. For that, I'm going to import it the grid search CV sklearn model selections selection, and I'm going to importing here the grid search CV, and also I'm going to initialize here my SBC, call the SBC equal to, let's say, SBC, and I'm going to giving here my probability. So let's make the probability should be the true. Then after that, I'm going to initialize my all of the parameters that is really available inside my SBM, or I can say the SBC also, support vector classifier, because this is a classification task. So I'm going to create here a variable that's called the parameters, and let's assign into the parameters. We have the two parameter. First one is called the gamma, so another one is called the C. So I need to select the best hyperparameter from this SBC. So that's why I'm going to give here some random number of gamma value. So let's say 0.001, and we having the 0.001, we having the 0.01, we having the 0. Just one. Okay. Now I need to also give here my value of the C. So C value. So what I can do, I'm simply going to give here some random value 0.01. Let's say 0.05. Let's say 0.5, 0.1. We have in the 1. Let's give in here 10. Then we have the 15, and we have in the 20. Okay. Now what I can do, we can use the grid search CV in order to select the best features column, I mean best parameter from my parameters. So for that, I'm going to using here this grid search CV, and after that I'm going to using here my SBC, I mean this instance, and after that I'm going to passing here my parameters that actually selected here, and now from this parameter it will try to searching my best parameters. So I'm going to using here my grid search equal to grid search CB, and inside that I'm going to passing here my SBC and also the parameters. Now let's try to fit it out. So let's say grid search dot fit, so dot fit, and I'm going to using here my data set, so X train and also the Y train. So now let's checking for that what kind of value we got. Okay, it will take few seconds in order to training this data set because it will select in the gamma value. Now you can see here it will actually using the grid search CB, and estimator is actually using the SBC. Now what I can do, we need to select the best parameters. So for that, I'm going to using this grid search CB and try to use the best parameters. So you can see the best parameter params, and you can see the best parameter is nothing but the C15, and gamma is 0.01. Now let's checking for also the best score. So let's going to copy this out. Let's copy this out. Okay, and I'm going to make it best score. So we're having the best scores. So let's see, we have 98% accuracy on the test data set, I mean training data set. Okay, now what I can do is simply going to using this best parameter, all the C and the gamma in our SBC. So for that, I'm going to using this SBC one. So call SBC equal to SBC, and I'm going to passing here my C equal to 15, and my gamma equal to 0.01, and my probability is always true. Now I'm simply going to using the same thing here. Where is it? Okay, I don't need to do it here. I can simply using here the sbc.fit. Okay, sbc.fit, and I can simply using here my x train, and also the y train. Simple. Now we have our data set. Now we can checking for the predictions. So you can using here the sbc.predict on our test data set. So test data, and let's assign it the variable called the y predict. Okay, y predictions. So you can do it same thing as it is here. and this is my prediction value. So now what I can do is simply going to checking for the accuracy score and also a classification report and all of the things. So I'm going to copy these things from here because it's necessary. Okay, so you can using here the SBC. We're simply going to make it canon to SBC accuracy, canon to the SBC accuracy, and try to make this canon to the SBC. Okay, done. Now shift enter. Now we have a 98% accuracy on the training data and 98% accuracy on testing data. Okay, that's when accuracy is also increases. If I see here, it's 95%. It's having the 96%, and okay, that's it. Okay, 96%. Now we actually increase it to the 98% on the testing data set. Quite good, quite good, quite good. Now let's also try for the decision tree classifier. So let's take some shell. So let's check it for the DT or DT, also called the decision tree classifier. So let's input it. That's from sklearn dot tree. I'm going to importing here the decision tree classifier. Then I'm going to create one instance. Let's call the DTC equal to decision tree classifier, and decision tree classifier also having some hyperparameter. So you can also do the hyperparameter tuning on the decision tree classifier. So for that, I need to also initialize here my parameters. So parameters, and let's say it having certain parameter inside the decision tree classifier. Okay, inside the decision tree classifier. So what I can do, we can give here the parameter of them. So it having the first parameter called the criterion. Okay, criterions. So criterions having the two features column and two value. One is called the Gini, and another is called the entropy. So entropy. Okay, if you know about the decision tree classifier, then it having the another value. Okay, it having thoda sa mistake ho gaya. Okay, it having the another value called the max diff of your decision tree. Okay, depth. Okay, and make it inside a range. So let's take one range so that it select the best from here. Let's say 2 to 32 on the features column, and let's give here the one so that it can go like that, 2, 3, 4, 5 like that. So it having now another parameter that's called the min samples leaf. Okay, leaf. So let's give here some range. So let's say also creating one range functions. Let's give here range from 1 to 10 and difference 1, and also it having the min sample split. So let's say min samples split. So what I can do, you can simply using here the range functions. So range functions, let us study from the 2 to 10. Let's make it 1, and it having the splitter. So splitter, so it having the batch splitter or the random splitter. Okay, two types of splitter are available inside the decision tree. So let's give here the batch to the random. Which one you're going to select? So random. Okay, now this is my parameter. So now what I can do, I'm simply going to pass it inside my grid search CB. So for that, I'm going to let's using the grid search CB. It's already imported in my kernels. If I see, we already imported it here. So what I can do is simply going to passing here my DTC and also my parameters. These parameters, also giving here the fold. So let's give here the fold 5 fold and jobs नहीं चाहिए मुझे -1 equal to -1 barbos. Okay, barbos, make it 1. Okay, so let's try to assign it to the variable. Let's call like grid search. Let's say grid search. Let's say dt. Okay, dt. Now you're going to simply going to fit it in our data. So fit our xtrain and also the y train. Okay, now you can see here it is feeding the 5-fold of the each 8640 candidates. So it's quite long. It will take few minutes in order to checking for the parameters which one is the best. Then after that we can checking for the best estimator, I mean the best parameter, and also the best score from my decision tree classifier. So for that we need to do the same things just to do earlier in the which one, SBC. So we can actually using here the same thing, git search dt dot best params. So best, we have in the best params, so it's not actually loading because it's take time. इतना टाइम लग रहा है भाई, तो इसको यहाँ से कॉपी करते हैं. So let's try to paste it here. This for the best params, and we have in the best score. So best score. So I'm going to type it here, the grid search cv, grid search dt search dt dot best score. Also it will give me the best scores, so it's also loading it here because it take time. So when it's loaded, let's take 2 minutes for actually training this out. Now I'm going to using here the best parameter and also the grid search dt dot best score. It having a 96% accuracy on the training data set, and this is nothing but my parameters. Okay, max depth is 15, and the mean number of samples leaf is 4, and we have our mean sample spreader is 5, and the spreader is nothing but random. So what I can do is simply going to using these things inside my decision tree classifier. So I'm going to using this DTC. So let's call decision tree classifier, and I'm going to passing here my criterion. So let's using the criterion is nothing but my entropy. So we can also copy. Okay, no, we cannot copy it here from here. Entropy. Okay, then we having the max depth. Having here the max depth is 15, and we be having the mean number of sample leaves. So mean sample leaf is nothing but 4, and we having the mean sample split is nothing but the 5. Then we having the splitter equal to random. So split equal to random. Just going to copy this of random. Okay, and now I am going to assign it inside a variable. Let's call the same variable name. Let's call the DTC. Okay, so I'm going to copy this from here, DTC, and I'm simply going to using the fit and using the X train, and I'm going to using the Y train. Okay, so it's loaded. Now you're going to checking for the accuracy score and all of them things. So I'm going to copy this out from here, the same thing, and I'm going to paste it here. And now what I can do is simply going to copy it, and let's make it DTC accuracy, this DTC, and also make it DTC and DTC. Okay, so you can see here we have in a 96% accuracy, 92% accuracy in testing data set. So this is how you can also select the best parameters in your data set. It's called the hyper parameter tuning. Now what I'm going to do, it's also the same thing for the random forest and also the gradient boosting algorithm. So now what I can do, I'm simply going to paste here all the code, and I'm going to pause the video because all the things are same, right? Just after that, I'm going to discussing these things, what actually happening here. Okay. Well, so you can see here, I actually passed here all the code. First, actually using here the random forest classifier, and also give here the criterion is entropy, and max depth is nothing but 10. So max feature is nothing but 0.5. So it having some technique that you have to follow when you are going to using here the max depth as a 10. You know, also using here the max number of features for the 0.5. So it has been and pictures. I have in pictures. So in this picture, you can see when you actually using the max number of features is 20. You need to using here the max features. You need to using here the 1.0, and when you have the 15 at the max feature, you need to using the 0.75 as the max number of features. So just you need to follow these techniques when actually using the max depth and the max features. So make sure you're actually using this technique, to when you're trying to building any random forest classifier. Okay, so what I can do is simply going to predict it using the random forest classifier, and after that we do the same thing that we do earlier for the decision tree or the SBC, even though the logistic regressions. Then we have in the gradient boosting classifier, import it, and we have some parameters. So first parameter is called the loss, and we have two kind of loss, exponential loss and the deviance loss, and we having one extra parameter that's called the learning rate. So we give here the learning rate as 0.001 and also 0.1, and number of estimator I just give here 100 150 and try to choose the best parameter using the grid source cv, also called the hyperparameter tuning that then we select the best parameter and also check that best scores 0.95, and you can see here we also using here the same thing that we do earlier, and We also import here the XGB classifier and give here the binary logistics, and learning rate is 0.01 and max depth is 5 and number of estimated is 180. So same thing as it is that we are do earlier. Okay, you can see here we're having the 96% accuracy on the testing data and 99% accuracy on the training data set. So we're actually using here logistic regressions. Use here the SBC support vector classifier, decision tree classifier, random forest classifier. Then you having the gradient boosting classifier, the XZB classifier. So now what you're gonna do is simply going to save the model, and after that, before that, you're going to also checking that which model is giving the best score. Okay, so for that, what I'm gonna do, I'm simply going to uh, creating one list of the my model and trying to pass in here my accuracy score inside my series, so that we can create one data frame of that. Well, so I simply create here one data frame which having the two column, one is a model and another one is a score. So I just simply going to multiply with the 100 so that it can give me the 96% accuracy like that way. So we have the logistic regressions, the KNN, the SBM, the decision tree classifier, and random forest, gradient boosting, and also the XZ boost. So now what I'm going to do, I simply going to short it out. Also, you can see here short value based on the scores and in ascending order, so that we can get here the best scores. So rand's classified accuracy is not actually available, and I think it should be the random forest. Okay, rand rnd rand clf. Okay, that's it. So now you can see here we get the best accuracy inside the SBM, or also called the SBC. Okay, so we got here 98.25 accuracy in the SBM, and after that we get here the random forest classifier also give me the 98.25 the value, I mean the classification score. Then we have our gradient boosting classifier 97.37. Then you have the 96.49 on the logistic regressions. Then in the SBM or SBC support vector classifier give me 98% accuracy, 98.25% accuracy. So now what I can do, we are going to store it inside one pickle format. So for that, I'm going to import here the pickle. So pickle, and after that, I'm going to take my model, is nothing but my SBC, and I'm simply going to save it pickle.dump. Okay, not sump, dump. Then I need to give here my model and also give here one name inside my open method. So here I'm going to giving here, let's say breast uh, cancer dot pkl. That I'm going to give here my mode. So let's give here the right mode. So it's save it inside my directory. If I go on here, just what you can see here, breast cancer dot pkl file, it's stored inside my directory. So now what I can do, I'm simply going to printing my all of the accuracy curve and also the ROC curve. So for that, I'm going to simply going to pass here the code because it's also necessary, and also try to checking for the performance of my breast cancer predictions. I mean, which model actually gave me the highest accuracy and also the highest ROC value. So for that, I'm going to pass here the code. Then I'm going to discussing this code on here. Okay. So I write here the code. So first what I can do is simply going to import here the sklearn. From sklearn, I'm going to import here the matrices. And after that, I'm going to using here the plt.figure, and I'm going to give here my figure size 8,5, and I'm going to select all the models inside my third bucket. So it having the labels LR mean logistic regressions and having my model. So you already initialize here our model name. You can see how initializing here the model name. You can see here just to wait. You can see here GBC. It's mean gradient boosting. Just when you initialize it here, we're just simply going to pass my model name, that's called the VBC. Then after that, what I can do, I simply going to use here my labels for the same all of the things. Model equal to SBC, the labels name, the labels DTC, XGBoost is XGB, the random forest RND classifier, and the GBT gradient boosting. Okay, so you can see here I give here also my model name and also my label name inside one a list. So now after that, what I'm going to do, I'm simply going to taking all the models name from my models, and I'm going to passing here inside my m, and I'm going to stack the model name from here. So when I try to extract it, I get here my classifier, and after that simply I'm going to using here the model.feed, and after that I'm going to using here the model.predict, and after that I'm going to selecting here my ROC curve. So we already importing here the matrix, and from the matrix I'm going to use here the ROC curve, and after that I'm going to pass here my y test and so the model.predict which model is coming from here. And after that I'm going to checking the first one so that it can give me the value of that, And I also using here the ROC curve with the accuracy, so that I can print it this ROC curve with the accuracy. So simply I'm going to using here the plt.plot, simple things, and just give here the x level and y level title, and also using here the save fix so that it can save inside my directory. Don't worry about this code. You can get this code in the video description of the GitHub link. You can grab the code from here. So you can see we got here the LR RSC cup area is 0.96, and in the SBM we have the area is nothing but 0.98. So that's why we got here the best accuracy in our SBM, also called the SBC. So after that, what I can do is simply going to creating one performance evaluation of the each matrices. So for that, what I can do is simply going to assign here the same thing inside my models, and after that I'm going to using here the mean accuracy that you did earlier, how you're trying to creating the data frame. And after that I'm simply going to do the same thing, the predictions and also the accuracy curve. And after that I'm going to simply printing in a data.plot, simply going to create some groups, and groups equal to 7 because we have the 7 model, and simply going to using here the means accuracy and the means ROC, and creating a plot of that. So that's how the plot is looks like. I'm not going to actually discuss about this thing because it's optional. You can also do it if you're trying to add it inside your research paper, even though you're final year or the thesis depends, you can actually using this performance evaluation matrix. So you can see here in SPM it having the higher most accuracy and also the ROC curve below. So that's it how you can actually building one breast cancer prediction model using some machine learning algorithm. You can also do the hyperparameter tuning using a grid search CB. So that's it for today now. Hope you enjoyed this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icon, and I'll be back with the another super advanced tutorial in this series. So thank you and bye bye.